All right, and so in this problem, we have a mass attached to a spring, as shown in this figure, and there's a scale attached to the end of the boxcar that reads 0 when the car is at rest. So, and then there's some questions about what's going on as the car moves. So let's write down the mass, and then I'm going to make sure I understand what that last line means by looking at the figure. So the mass is 5.00 kilogram, and then let's see. Okay, yeah, and then basically it means I think that the spring isn't stretched when the car is at rest. Okay. And so we want to get the acceleration if the spring has 18 newtons while the car is in motion. So let's write that down, that the force of the spring is 18.0 newtons. And our goal is to get, what was it? The acceleration. So we want to do a free body diagram on the mass. And so basically the mass only has, it has a normal force from the boxcar and the weight, but those are going to always cancel. We're not doing any vertical acceleration, but we do have this force from the spring pulling it to the right. And so that's the only horizontal force. So you can say the force of the spring is equal to ma. So you get A is the force from the spring divided by m. And so that's 18 divided by 5. So that's going to be 3.6 meters per second squared. And what if the car is moving at a constant velocity, what will the spring scale show? If it's at a constant velocity, then there is no net force on the object. So this Fs has to be 0. And and then we want to get the forces on the object by somebody in the car and then someone at rest outside the car. Okay, so, and for this part, I'm not sure if they want the forces on the object as someone in the car and outside the car while it's accelerating or not, because I think that if it's not accelerating, then the forces should agree. But so I'm going to assume that it's accelerating. And while if it's accelerating, then if you're inside the car, you'll see an additional fictitious force that would explain why the spring is moving. So let's see, inside car. And this is sort of inspired by that example in this section. So inside the car, sorry, I just wanted to scroll down and look at the picture. Then you'll see a fictitious force to the left, FF for force fictitious, and then some tension to the right, because you'll be like, well, why is it suddenly moving to the left? And that's because there's an acceleration happening. And then outside, not in this non-accelerating frame, you will just see the tension. And that's where I did this. So that's FS. So let me use that to be more consistent. I think I was a little influenced by that example when I called it T.